All right, you guys, we're going to try the video way to explain some of the free response that we didn't necessarily get to go into class. So let's see how this goes. Now, the first thing you want to notice on these types of questions is this is very similar to the quiz that we did. So read the instructions and make sure you're answering the question. This particular question is asking you to identify the type of bias as well as stating whether you think the sample proportion obtained is higher or lower than the true population proportion. Now this particular question talks about some rather risque artists, but they go around asking, rather than support government censorship of artistic expression, are you in favor of continuing federal funding of artists whose work may be controversial? Well, I'm kind of reading this and I'm thinking rather than support government censorship, no, I don't want the government to censor something. I want my freedom. Of course we're in favor of continuing this funding. So it's kind of forcing me to want to agree. That's kind of the wording is pushing me to agree. So I'm kind of thinking this 85% is too high. So what I've just mentioned is what I think about the sample, but in terms of what's wrong with it, I think the wording of the question is a little off. So I'm going to kind of show you behind my box, I said poor wording. The fact that they're talking about government censorship, it's kind of an issue there. 85% is probably higher than the true population. So notice I answered both parts of the question. I identified the bias and I said higher or lower from my sample in relation to the population. Okay. So let me scroll down here. Sorry, this thing is getting kind of annoying. Well, I know you guys can see my work, but I want to kind of talk about it without you guys being focused on it. So, in 2003, the AARP conducted a survey of the members, people over age 50 who pay membership dues, on proposed Medicare legislation. One of the questions was, even if this plan won't affect you personally, either way, do you think it should be passed on so that people with low incomes or people with high drug costs can be helped? First of all, I'm kind of looking at who we asked. We asked people over age 50 who pay membership dues. So I'm thinking these are members who pay a membership. They probably have enough money that they're willing to pay a membership to be part of the AARP. They're also over age 50. Those are on the older side. So I'm kind of thinking we're leaving out a group of people. We're leaving out younger people and maybe people who can't afford a membership. I would call that undercoverage. Undercoverage leaves out young and poor people or people who can't afford the membership. I'm not asking everyone. I'm not asking all adults. I'm only asking these types of people. So I would say that that is the issue. But in terms of figuring out higher or lower, I can kind of see two sides to this. What this one ends up being is 75% is probably lower than the population proportion. Young people tend to support helping people get through stuff that maybe don't have as much money because young people don't typically have as much money. So younger people would probably want to say yes. And poor people, of course, they're going to want to have help getting their high drug costs. So they're going to want to say yes as well. So I'm thinking this is too low. However, if you do say higher because you think that older people are going to have more medications, so of course they're going to want to help, I can see where you would say higher with that reasoning. So if you have a reasoning that supports the higher, I would probably accept it. But in terms of the answer key, we're going to say lower because young and poor people would tend to be supportive, but we left them out of the sample. So that's what I'm going to say for that one. Feel free to text me if you have questions on Remind regarding that question. All right. Does ginkgo improve memory? The law allows marketers herbs and other natural substances to make health claims that are not supported by evidence. Brands of ginkgo extract claim to improve memory and concentration. A randomized comparative experiment, or in other words, a completely randomized design, found no statistically significant evidence for such effects. They told you we had 230 healthy volunteers. They were randomly assigned either ginkgo or placebo, and all took battery of tests for learning and memory before the treatment and again after. So was the study double blind? What does this mean? Well, remember, double blind means neither the people that are taking the treatments know what they're getting, nor the experimenters or the people that are recording the results. So what I said here is neither the subject nor the person administering the test knows what treatments are being received. So that's what double-blind means. The two different sides don't know what treatment is being given. Comment briefly on the extent to which results of the study can be generalized to some larger population and to the extent to which cause and effect has been established. Some of you today talked about, well, how do we know what we're going to talk about? Like, do we need to talk about both random sample and random assignment? Well, again, in this situation, they're talking about and. Comment to the population and to cause and effect. So we're going to mention both. So in this case, did random selection happen? No, we did not randomly select who participated. So we cannot say that this is true for a larger population. So I said no random selection. We had volunteers. So we cannot generalize the results to a larger population. Now looking at random assignment, did we randomly assign treatment? It did talk about random assignment. They were randomly assigned to ginkgo or placebo. Therefore, because of random assignment, we can establish cause and effect. So this is an example where you want to mention both types of scope of inference. All right, part C. Explain why it is advantageous to use 230 volunteers in this study rather than, say, 30. Well, why is it better to use more volunteers rather than less? This kind of goes back to the example that I gave with the ACT versus the ACT classes, the class versus online. It'd be better to use more people. I can't just use 4 people and randomly assign 2 and 2. There's a good chance that 2 of the smartest people got put into one group. So in this case, 230 is better than 30 because of what we call replication. Replication has a larger number of subjects. We have more people being part of my study, and there's 2 reasons that are for this. Now, this is the wording straight out of the book. It decreases the impact of random variation on results. So in other words, it decreases the chance of putting the same type of subjects in one group and the other going in the other group. It's giving everybody an equal chance of going into the 2 groups. And then it increases the ability to distinguish the effects of the treatment. So if I know that I'm not putting all the healthiest people in one group and the sicker people in the other because I use random assignment, it's giving us a better possibility of saying that it's the treatment that's due to the change, not because of who got put into it. Okay. And then part D, explain what it means that they are not statistically significant. Ignore this up here. Not statistically significant means, if you remember, statistically significant was that the difference between them is so large that it could not have happened by chance. So if it is not statistically significant, then really I didn't see much of a difference between my 2 treatment groups. So what I said here is the difference in the results was small enough that they could be attributed to chance rather than the treatment. I didn't see much of a difference between my ginkgo group and my placebo group, so there's a good chance that the difference was just because of who I randomly put into each group. It's not because of treatment. That's what not statistically significant is. Now part E, using the random digits below, starting at line 103. Now they gave you the digits. Choose the first 4 members in the ginkgo group and explain your method. Now I'm just going to go ahead and show you all of the answers that I put here, and I'm going to talk about it. Notice that what I did is every 3rd digit I put a line. So I'm looking at 3 numbers at a time, and I mentioned that. But notice I said label the subjects from 001 to 230. It's important that you talk about how you label them, especially with table D. You need to talk about the fact that they all have to be assigned 3-digit values. So 001 to 230. We are going to choose 4 volunteers because it says choose 4. We have to talk about the fact that we're looking at 3 digits at a time. So you could either say pick 3-digit numbers, or you could say look at 3 digits at a time. And I'm only looking at numbers from the range of 001 to 230. You could also say skip numbers that are larger than 230. That would have been okay as well. But notice I also mentioned that we're skipping repeats. All right? So I've explained the process here in detail, and then I actually did the process. I skipped 454 because it was too big. I skipped 677 because it was too big. 170 though, that's in my range of values, so there's 170. I skipped too big, skip too big. I skipped 000, remember I'm kind of thinking of that as 1,000, that's too big. Too big, too big, too big. All of these are too big until I get to 005. Okay, so that would be the 5th person in the group. Again, too big, too big. I don't even think there's any repeats here, but I would skip repeats if I had to. And then you get to one that's in the range, skip, and then you get to the last one that's in the range. So these are the first 4 people that are in the range of 001 to 230, and there were no repeats. So again, you have to explain it in detail, and then you have to actually go through the process and find them. Now, some of you may have said label it from 000 to 229, and technically that's 230 people, and now you would have had a slightly different result down here because of the 000, and that would have been fine as well. I would have taken your result, but I think it's trickier to do it that way. I don't suggest starting your labeling with 000. I suggest starting it with 001 and reserving this number for the 1,000th person. So there's technically 2 ways you could have gotten answers there, but this is probably the most common way of doing it, and this is the way I suggest you to try. All right, the last one, again, is on an experiment. We're talking about high blood pressure here, and we have these ACE inhibitors. We want to test the effectiveness of them as a treatment for high blood pressure. So it's well known that men and women may react differently to common cardiovascular drug treatments. What sort of design would you choose? Well, I know you can already see the answer here, so I'm just going to say it's a randomized block design. We're going to block it by gender. Remember, men and women act differently, especially with blood pressure. If I were to put men and women in the same group and test the results, you might have a dot plot, and maybe women's blood pressure might be over here, and then you might have men's blood pressure over here. Well, that's a lot of variability if you say it goes all the way from down here to here. But if you totally split them up, women might have one right here, and men might have it like way out here, but if they're on 2 different scales, notice the variability is much different. The women are much smaller, and so are the men. So what it does with blocking is it reduces the variability amongst the genders because we know that they're going to be different from each other. Now the textbook answer is blocking reduces the impact of differences in responses of men and women. But again, it's basically reducing the variability between them. That's why you'd want to block a randomized block design. Now, for this next one, replication again, we brought this up on the front page. Why is it better to use 600 men and 500 women versus 60 and 50? Again, replication does 2 things. It gives you enough people that you could say that the differences between them is not due to chance. It's because of the treatment. Those are the 2 things. It's not due to the random variation, so it reduces the impact of random variation, but it is because of the treatment. It increases the ability to distinguish the effects of the treatment. Again, these are more of the textbook answers, but if you say it allows it to say that it's not due to chance and it is because of the treatment, that would be good enough of a response for me. Now, I have 1 more minute before my video is going to expire. So I'm just going to kind of show you guys here that there's a picture. I blocked it by men and women. Make sure you mention random assignment here. And actually, I think I'm just going to make a second video explaining this last one. My video maker only allows me to get to 15 minutes, and I'm at 14 minutes. I won't have a minute to answer this. So just click out of this video and then look at there's 1 more link in my calendar. Click on that and you'll see the remaining video for how to do this problem.